Imagine a computer working like the human brain. That's what neuromorphic computing is all about, building machines that think like we do. Today's computers are fast, but they're inefficient when it comes to tasks involving vision, pattern recognition, and learning. They rely on traditional learning architectures where memory and processing are separate, and this requires a ton of energy. So, for decades, scientists have looked at nature for design inspiration, and they realized that no system is more powerful, mysterious, and interesting than the human brain. Today, the brain isn't just something that we study, it's something that we've started to replicate in AI, in robotics, and in hardware. Hi, I'm Shreya, and welcome to my series Earth Engineered. When we train AI models or render graphics in a video game, we usually use something called a GPU, or a graphics processing unit. Unlike a CPU, or a central processing unit, which has just a few powerful cores for general tasks, a GPU has thousands of smaller cores designed to handle lots of things at once. That parallelism makes GPUs great for AI, and they still use a lot of power and process information very differently from how our brains do. Our brains are different. We process information through a bunch of neurons and synapses. They only fire when they need to. They're parallel, event-driven, and incredibly powerful, running on about 20 watts. That's less than a light bulb. Neuromorphic chips mimic how real neurons work. They use what's called spiking neural networks, where data is transmitted in spikes, or bursts of activity, just like the brain. These chips integrate memory and processing, making them fast and energy efficient. Companies like Intel and IBM have already built these chips. Intel's Loihi can simulate millions of neurons while using way less power than a GPU. IBM's True North has over 1 million neurons and 256 million synapses, and it runs on just 70 milliwatts. This kind of computing is perfect for edge devices, like small cameras, wearables, or autonomous drones, where you need real-time processing but can't afford to waste power. It's also being used in brain-machine interfaces and robotics. But there's another piece of this puzzle, and it's called NeuroAI. While neuromorphic computing focuses on the hardware, NeuroAI is about designing smarter algorithms by studying how the brain actually works. Researchers are asking, how does the brain react, learn, and adapt, and how can this be used in artificial intelligence? NeuroAI and neuromorphic computing are two sides of the same coin. NeuroAI gives us brain-inspired models, and neuromorphic computing gives us a faster way to compute information similar to the human brain. Whether we're making chips that fire like neurons or creating algorithms that learn like the human brain, neuromorphic computing and NeuroAI are opening doors to a new type of intelligence. We're not just making faster machines, we're making smart, adaptable ones too. While we're still in the early stages, the future potential is massive. Thanks for watching and hope to see you in the next episode.